Hello, everyone.
Hello.
Yeah, are you all able to hear me? Okay, great. So today's topic, as you all know, is the complexity analysis of algorithm. So today's topic is complexity analysis of an algorithm. That is all the questions that we have solved so far. We are going to see, okay, how much time that particular problem is going to take to execute. Clear? Basically, if we talk about the complexity, it is nothing but the time complexity and the space complexity. It boils down to the main two things, that is time and space. Yes, guys, what happened? All of yours energy is down today.
Actually, I'm not able to send message. It's going to Ashok IT not in meeting.
Try sending it again now.
No, again, same problem. Shall I log out, log in?
Yeah, sure.
Okay.
So now you all know I'm giving you a very simple questions. Question is that you have been given a number n, that is, let's suppose is 24, and you have to tell me all its divisors. All of you, do you know the meaning of what is divisor? If not, let me tell you. All the numbers which can divide 24 are known as its divisor, like 2, 3, 4, 6, then comes 8, then comes 12, and then finally comes 24. So all of these are the divisors of 24. So you all have to write the program for this particular thing. Are you all clear? Yeah, one also. Okay, do it quickly and tell me when you are done. I'm giving you all 2 minutes of time.
So I'm logging out. It will be back.
Yeah, sure. Okay, I can see most of you have figured out how to solve this question. If you want to find all the divisors, then you know, let me just write the function quickly. Int divisors. Int divisors in the sense that you have to send the total number of divisors a number is having. Okay. Here I'll be sending you the number. Then I will initialize my count equals to 0 as of now. From where should I start my loop with? As you all can see that 1 is also the divisor. So 1 is also considerable. So we should start our loop from 1. Next thing is it should continue up to n, correct? And the next thing is at every point you need to increase your number. Everyone clear with this or not? Okay. Then here we will check if whatever your number is, if its modulus with I is equal 0. That means it is completely divisible by I. If this is the case, in that case, you need to increase your count. Everyone, are you clear with this or not? And at the end, when you are done with your for loop, you need to return your count. If anyone is facing any problem in this particular code, you can just tell me right now so we can discuss it. Otherwise, I will move forward. Clear. Great. So now in this particular case, how can we calculate the time complexity? Okay. For initialization purpose, how much time does a particular statement takes? Yeah, just assigning count equals to 0. How much time should it take? It's just an initialization operator, so it won't take more than order of 1 time, or we can say a constant time. Aman, it should not be n, it should be order of 1. I hope you are clear.
No, I'm not clear. Why one?
Just a minute.
No, why I'm thinking is because
Mm-hmm.
count will keep on incrementing as the number increases, so it will be directly proportional.
Actually, I'm just talking about the initialization part. I'm still not talking about the increment and all.
Sorry.
Okay, just a minute. Just a minute. Okay. So for initialization, you all agree that it is gonna be order of 1. Yes. Anyone who is unclear with this particular thing, they can just let me know. Is that means if we are initializing the primitive, the complexity, anything you are initializing or you are giving the value on your own, don't you think it is gonna take like order of 1 time or constant time? Again, if this is the if condition, okay, in the if condition, it will just simply divide the number and check if it is equal 0, like the mod is equal 0. So dividing a number with a certain value and checking if it is equal 0, is it going to take somewhat variable time or a constant time? It's going to take a constant time. Clear? Again, incrementing the count also, it's just like it is incrementing value each time. Okay. So for now, if I just see it as a simple statement, count plus plus, what will I say? how much time will it take for incrementing a number? And don't think about the loop. Just think about this particular statement and tell me how much time should it take? It should take again order of 1 time. Clear, guys? So here I am writing it's gonna be order of 1. I hope it is clear to everyone. Great. Now talking about this for loop, how many times this for loop is gonna continue? How many times this for loop is running? It is running for n times. Okay. So for the first time, it will come, it will execute these order of 1 statements. Then for the next time again, it will come, it will execute these order of n statements. That means it is gonna execute these order of n statements for order of 1 time. Yes or no? Sorry. Okay. So these order of 1 statements are gonna execute for n time. That is, I can write it like this. N into order of 1. Yes or no? Hence, we can write here overall it is going to be order of n time. Why n? Because you never know that what is this n value going to be. Correct? Okay. So did you all understood what's happening in this particular program? And how we are calculating the time complexity? Again, at the end, return count. It is just returning a value. How much time it should take for the returning? Again, a constant time, that is order of 1. So I now am assuming that you all understand the difference between constant time and the variable time. When you are in a loop and that loop is running for, you can say, n number of times or m number of times, or the value that is not known, in that case it is variable. But if it is just a simple if statement, return statement, increment operator, initialization, everything, these kind of like statements comes under the constant time. Is it clear now? Guys, is it clear?
Ma'am, I have a small question.
Yeah,
Like,
yeah.
for example, the value of pi. So, and increment of 1, even though it's a constant time, but the time consumed in calculating pi value and just adding.
Can you come again?
Yeah. So if I say in one statement, x equal to 22 by 7, and that x is in like big number or in double, that will take relatively more time, whereas x equal to x plus 1 will take very less time.
Actually, Vishnu, like 22 divided by 7 plus 1, it's not anywhere seen that, okay, division, it's going to take more time. Because you know that like we are running all our programs in the computer and it is the fastest machine considered, right?
Yeah.
So far, all the time complexities when considered, it has been checked that all the operations, no matter the value is in double, int, it may give slight variations, but when overall it was considered into picture, the figures, it came out to be as a constant time. So I'm not saying exactly it will execute in 1 second, or like I can agree with you in the fact that, okay, integer operation will execute faster. and the double operation will execute a little late. But that fraction of seconds are so small that it is not even noticed. Is it clear now?
Okay. So I was thinking that could be one of the ways of variation, but okay,
Like,
that.
see, if I tell you that the integer addition operator is going to execute in like 0.5 times 0 and 1 second, okay?
Mhm.
And let's suppose the double operation is happening in 0.4 times 0 and 1 seconds. Like, it doesn't make much sense, right?
Okay.
Anyways, if we see, it is like very, very less than 1 second, and hence it is considered as a constant time.
Okay.
Anyone else having any questions in this? Yes, guys, you can quickly ask your questions. Otherwise, I'll move ahead. What is O? Okay. This O that I am specifying here, it is nothing but we name it as an big O notation. And what is the significance of this big O notation? It always helps us know the worst time case complexity of a particular program. Are you guys clear? There is one more term called theta. So theta gives you the average time complexity. And similarly, there is one more, I don't remember, maybe omega, it is there, which gives you the best time complexity. So one is for the best case, the best case time complexity. Theta is for the average case, and big O notation is for the worst case. We only learn about the big O notation because we always want to know what is the worst possible situation that our program can run into. Clear, everyone? Now, the other question is that I am going to ask you all, why are we always considering the worst case? Why are we not considering the best case or the worst, like the average case? Anyone has given the thought to this? System may crash, okay. But this is a competitive coding question. Think in that terms. Yeah, but Vishnu, that point is correct. Performance issue, okay. See, because the the test case that generally is being set, okay, the test case are being set by the question setters, okay. So they always somewhere gives the extreme number as one of the test case, okay. So in that extreme case, your program has to run for the worst case, right? It cannot just execute up to the average case and give the answer. Are you all getting that? And that's the reason why always we consider the worst case, because otherwise if we don't consider the worst case, program will run, but in the, you can say, in the worst case, it's gonna fail. Okay, now, so if you all understood these things, now let's discuss few things here. In our program, our, like in our particular program, in 1 second, 10 to the power 9 instructions can be executed. Are you all getting this? Now, what do I mean by instructions? Instructions in the sense, you can say this comparison is one instruction. This increment operator is another instruction. This modulus operation is another instruction. Then checking if the number is getting equal 0 is going to be another instruction. And similarly, there are so many instructions in your program. Okay. And in our entire program, like with this collection of state instructions, they execute in 1 second if they are like equivalent to 10 to the power 9 or less than 10 to the power 9. Everyone, are you able to follow this? Okay. Did you all understood what are instructions? Okay. So now here, I just told you 4 instructions as of now. There will be many. I am assuming that total there will be 10 instructions inside, like in this entire program. This is, I'm taking it as 1. Sorry, 4 has happened now, 5. Then here it is going to be 6. Correct. Each individual step is instruction. 7. This is also going to be count. That is the initialization part, 8. As of now, I can see the 8, amongst which we will not count the outer initialization part because it is just like getting initialized. We are not going to count the initialization of I because again, it is just a one-time thing. We will only count the instructions that are going to execute in the for loop. So this is 1, 2, 3, 4, and 5. Total 5 instructions are getting executed inside the for loop. Yes or no? Okay, now tell me, if I give my n value as 10 to the power 9, how many instructions will be executed? It will be approximately 5 into 10 to the power 9. Yes. Now, in how many seconds will it get executed? It will get executed in 5 seconds. And generally in the programs, if you see or if you solve, there is always given a time limit, yes or no? Have you ever seen that? And generally the time limit ranges between 1 second to 2 seconds, not more than this. So if your program is going to execute in 5 seconds, what error it is going to give? It is not going to execute in the time limit, right? So it is going to give you the error, time limit exceeded. Basically, this particular error is known as TLE. Clear? So you always need to make sure that no matter what, the number of instructions that are running in your particular program should always be either equal to 10 to the power 9 or I should be less than that. If you are doing it in a more quantity, then it is going to give you a TLE. Clear, everyone? Okay. Now, you all understand that let's imagine if I overall consider these entire stuff like inside the for loop as one instruction, then in how much time your program is going to execute? I will repeat myself again. If I consider all the number of statements inside the for loop as a one instruction, then how much time will your program take to execute? Vishnu, I am not talking about the number of instructions it is going to execute. I'm talking about the time. Overall, it will execute 10 to the power 9 instructions, and the time taken will be 1 second. Clear, everyone? How many of you in the class are still not clear of what I am teaching? Guys, be little quick because so many people in the class, but only few are responding. Okay. Now I am trying to double this thing. Double not, I'll just say if I'm trying to give 10 to the power 18 as an n value. Right now n was 10 to the power 9. Now I'm giving 10 to the power 18 and the condition is the same. In how much time will your program execute? Okay, just see this. If these many instructions are getting executed, how much time will this take? 2. How much time will this take? 3. How much time will this take? Good. So for 10 to the power 9, I can write it as 10 to the power 9 into 10 to the power 9. So in how much time it will execute? Yes, guys, in how much time it will execute? Bhuvnesh and everyone else, check your answers and think. If this is 2, it is taking 2 seconds. If this is 3, it is taking 3 seconds. So if this variable factor is 10 to the power 9, then it will take 10 to the power 9 seconds now. How 2 seconds and 1 second is something you are getting as an answer? Yes, Bhuvnesh and Jyotsna. Are you guys clear now or do you have the doubt still? And Bhuvnesh, are you clear? Guys, respond fast. Okay. Okay, then, if you all are clear. So you all can imagine that if I give n value as 10 to the power 18, it is going to get executed in 10 to the power 9 seconds. Yes. Approximately, can anyone tell me how much these 10 to the power 9 seconds means? Like you can tell me it in terms of days or hours. Just calculate and tell me how much time is it. I'm giving you 2 minutes of time. Calculate and tell me. Use calculators, no worries. Try to convert it in years then, if the days and hours are such big numbers. It's approximately 31.7 years. Which is nearly equals to 32 years. Okay. So if I give, like if I start this program today, after 32 years, it is going to get executed. All of you, are you able to follow this? And do we have this much time for the execution of a program? No. Hence, there came the technique of optimization. Optimization in the sense, if your current program is taking so much time with the big numbers, then try to optimize and see if you can do any better. Clear? All of you, are you clear with this? Okay. Now for this particular program, how can we optimize this? Let's see. If I give my number as 100, like the number as 100, the factors, like the devices for this will be 1, 2, 4, 5, 10, and 20. Can you tell me the other devices for this after 20? $25 and $50. Okay. 25, 50, 100. Anything else? No. I'm just finishing off this table really quick. So you can see if 1 is divisible, like if 1 divides 100 completely, then 100 is also able to divide it. Yes or no? If 2 is dividing 100 completely, then 50 is also dividing it. And 50 is nothing but its quotient. You all know what quotient is, right? If 4 is dividing 100, then 25 is also. And if 5 is dividing, then 20 as well. Same goes with 10, but in 10 case, like it's the same. But yeah, 10 in that case of 10 is also the same. And after this, you will see the things are getting starts getting repeated. Yes or no? Up to where our loop actually went? Like up to where should we loop it? Kishan, if it would have been n by 2, then our loop should run for 50. How many times it is running here? 5. I'm asking about the maximum value it is running up to. Guys, understand this. If you divided 100 by 1, how many divisors you are getting? If 1 completely divides 100, this means that 100 is also going to completely divide one, like 100. Yes or no? So if you're trying to divide 100 by 1, you are going to get two divisors here, 1 and 100. Then you will try to divide it by 2. It is completely divisible. Again, you are going to get two divisors. Then you will check for 3. Will 3 be able to divide 100? No. Then you will go to 4. If 4 is completely dividing 100, then 25 will also. How many divisors you will get here? Again, 2. Same goes with 5. Then it will check for 6, 7, 8, and 9. Does any of this number is divides 100 completely? No. Then it will go to 10, and here again it will be completely divisible. Yes or no? But how many factors you will get here? Like divisors you will get here? One only, because 10 is getting repeated. Now, will you again continue your loop for long time? Like, will you go to 20 again? You have already taken 20 into consideration. Will you all again go for it? No. So up to which value your loop continued? Up to 10? Yes or no? Okay. Now I am giving you all one number. Let's suppose I am giving you all the number as okay, 89. Let's see. Don't take 89, take 88. And tell me how many divisors are there. And solve it in this manner only, like the way I explained you right now. Okay? Do it quickly and let me know. Okay, I got one answer. Let's see if it is correct or not. I will go with 1. For 1, I'll get 88. With 2, I'm going to get 44. With 3, is it divisible? No. Okay. Then I am going to take 4. With 4, it is 22. Then with 5, 6. Okay, directly with 8, it's 11. After this, you will again get 11 and 8. Yes or no? So overall, it continued up to 8. Yes or no? So I want you all to see these two observations of 100 and 88 and tell me up to how many times your for loop should run. 10 times. Okay, then let's clear that thing. Vaibhav, you take the example of 1000 and tell me how many times it should continue. So I am writing here n equals 2000. Try to find it out and tell me. Not in the normal approach. Try to find out the divisors in my way and tell me. Be quick. Vishnu, are you sure? Are you sure that it is going to be 2? Like 4, 5? Guys, quickly tell me. Okay. Let me just quickly write it. With 1, you are going to get 1000. With 2, you are going to get 500. 3, not possible. 4, you are going to get 250. Then 5, you are going to get 200. Then 6, 7, 8. 8, is it possible? It is possible. With 8, you are going to get 125. With the 9, it's not possible. With 10, it is possible. 100. After 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. With 20, it is possible, right? Yes or no? How much? With 20, you are going to get 50. Then 25. How much? 40. Then any other possible way? Are you all sure? Okay. So you all can see up to where we should run our loop now. Till 25, right? And Vishnu, I hope your doubt get cleared now that you were saying only up to 10 we should run, but you can clearly see here that it is running up to 25. Correct. Kishan, good observation. Everyone else in the class with these 3 examples, did you figured out anything up to where your loop should actually continue? Kishan got it. The remaining ones I'm talking about. if you all can see here, it is roughly running up to the square root of a particular number. Clear? For this, like for 100, the square root was 10. So it was running up to 10. For 88, roughly, the square root will come out to be 81. Sorry, 9 it will come out to be. But when it will check with for 9, 9 is not going to be the divisor. Hence, it ends at 8. Clear? For n equals to 1000, it is going to come out somewhere around, I guess, 30 or 35 in between that. But the last divisor that we have for 1000 is 25. So your loop is running 10 or 20 times extra, but it is not at least running 1000 times. So which approach is better? Square root approach is better. Hence, this way we will optimize our particular program. Now, let's see the difference. Previously, if your n was 10 to the power 9, previously your n was 10 to the power. Now I am taking here your 10 is equals to like n equals to 10 to the power 9. How many iterations is what it was taking with the previous approach? Guys, be quick. It was taking 1 second. I'm talking about 10 n equals to 10 to the power 9. Sangram. For n equals to 10 to the power 18, it was taking 10 to the power 9 seconds. Clear, everyone? I am still talking about the previous approach. According to the current approach, we are taking the square root. So if n is equals to 10 to the power 9, automatically our number of instructions are going to reduce to the square root. And here you are going to get approximately 10 to the power 4 or 10 to the power 5, which will obviously take less than 1 second. Yes or no? Next is in this case, n is equals to 10 to the power 18. In this case, how much time will it take? Square root of 10 to the power 18 will be? It will be 10 to the power 9. Hence, it is going to execute in 1 second. Clear, everyone? So this is how we optimized our code and reduce our time complexity. So the previous approach that we wrote was known as like the basic approach, or we name as the brute force. Okay, brute force is nothing but the very basic solution you can think for a particular program, and it should be a working solution. Okay, next comes the optimized solution, which we right now did. And hence you got your time complexity reduced. I hope all of you got a very, very, very clear idea today about why I'm always telling you guys, okay, can we optimize our code? Can we like try to do it in a better way? Because I know that the whatever solution you all are thinking, it is going to execute, but not in the specified time limits. Clear? Okay then. So today was just an introduction, nothing else. Tomorrow on, I will just give you few more algorithms to analyze with the for the time complexity, and we will see little more concepts of the time complexity in the coming classes. Okay, everyone. Okay then. So yeah, I'll
Hello.
see you guys